every meeting or so. But to go ahead and get to the presentation, we are just very honored today to have Mike Smith here. He's the Senior Vice President of the AccuWeather Enterprise Solutions of Wichita. He's a fellow of the American Meteorological Society, and he's a certified consulting meteorologist. His work has saved hundreds of lives and billions of dollars for his clients. If you haven't read his books, Warnings or When the Sirens Went Silent, I highly urge it. They're great books. I'll admit I haven't read Warnings yet, but I'm definitely going to do that at some point soon. When the Sirens Were Silent, great book. I enjoyed it. So, with further ado, Mike Smith.
Thank you, Matt. Make it a little easier for you to write the book, not read the book. Not that this author wouldn't like you to buy a copy. I am donating one to the library here, and I have autographed it, and it says, if I can get to that page, to the students and faculty of the University of Georgia, go Bulldog meteorologist Mike Smith. So, there you are, Marshall.
Thank you.
Now, a lot of times when people come in from off campus and talk about careers and things, they give you a lot of boring statistics. I might be boring, but it's not going to be because of statistics. What I'm going to do this afternoon is maybe reinforce why we have chosen this fantastic profession that we are part of. I often talk about meteorology and atmospheric science as being the Rodney Dangerfield of science. We get no respect. People come up to me all the time and say, it must be nice to be able to keep your job when you're wrong half the time. Well, in 2011, 551 people lost their lives in tornadoes in the United States. Does anyone know what percentage of those people were in both a tornado watch and warning before the fatal tornado arrived? Anybody want to guess?
100%.
No, not 100. The answer is 99.3%. The point is, name one other predictive science that could have achieved that level of reliability that would have allowed all but 6 of those people to save their lives. What we're going to do today is we're going to talk a little bit about how the tornado warning system came to be, how we meteorologists sort of put this thing together a piece at a time, because after all, there's been a war on cancer, but there's never been a war on tornadoes declared by the U.S. government. And then we'll talk about careers in meteorology if you'd like, or I have a special bonus presentation, a little bit about what went wrong with the warning system in Joplin, and it's something that we want to make sure never occurs again. So let's go back about 60 years. Today, for the younger people in the room, it is very hard to imagine the extent to which tornadoes terrorize the country. People were afraid to go to bed if a thunderstorm was occurring in the central United States and in much of the South. And with good reason. In 1947, the Woodward, Oklahoma tornado killed 181, injured 1,500. In 1953 in Waco, 114 were killed. 6 weeks later, outside of Tornado Alley, Flint, Michigan lost 115, and the very next day, 94 were killed in Worcester, Massachusetts. 6 were killed across the border in Vermont, making it another triple-digit tornado fatality day. Why was that? Well, the reason is, since 1888, the Weather Bureau forbade itself from issuing tornado warnings. They were afraid that panic would ensue and, quote, more people would be killed by the panic than would be killed by the tornado. And that ban on issuing what we call a tornado warning today was still in effect in Oklahoma and south central Kansas on May 25, 1955. The forecast that morning was, quote, mostly cloudy with off and on thunder showers. Now, the U.S. Air Force was well ahead of the civilian world. They had an experimental tornado warning program at Tinker Air Force Base in Oklahoma City. And they had a converted World War II radar that they used to track thunderstorms. And about 6 p.m. Central Standard Time, they were on Standard Time even though it was May, the sergeant on duty at Tinker Air Force Base's weather station saw this very large thunderstorm form over Oklahoma City and begin moving almost straight north. Today, we would know that storm to be a supercell. But that term hadn't even been coined in 1955. Now, I realize these tracings, made on a sheet of yellow teletype paper, don't mean very much today. So, what I've done is I've taken the tracings and put them on an ordinary map. Tinker Air Force Base is here, downtown Oklahoma City, and you can see the storm beginning to move to the north. Now, keeping in mind it was standard time, shortly after 8 o'clock, 5-year-old Don Burgess was standing outside student housing at Oklahoma State University with his dad, watching the spectacular lightning from this thunderstorm. In fact, if you go look at WeatherWise magazine, you'll see there's actually a scientific paper about the phenomenal amounts of electricity this thunderstorm was producing. And as the sun slipped below the horizon, for the first time in his life, Don saw a tornado touch down. And it reinforced in his mind that he was going to be a meteorologist someday. Tornado number 1 from that supercell didn't do much of anything. Tornado number 2 formed near the town of Tonkawa, Oklahoma, southwest of Blackwell, destroyed a few outbuildings and lifted. Then tornado number 3 in the series hit the east side of the town of Blackwell, completely without warning, about 9:30, and killed 20 people. It was F5 intensity, rated retrospectively. Tornado number 3 had a longer path than the first 2. It continued to move to the north, crossed the border into Kansas. It lifted while tornado number 4 was forming just to the west of the town of Arkansas City, Kansas. That was right at 10 o'clock. The TV meteorologists were going on the air at 10, and they were telling their audiences, quote, all weather advisories have been lifted for the night. They didn't know that Blackwell had been hit, and they didn't know that tornado number 4 had touched down just to the west of Ark City and was making its way north. About 10:15, the tornado passed east of the town of Oxford. And what happened next is better told in the words of a woman who wrote a letter to the then head of the National Weather Service, then Weather Bureau office in Wichita, Victor Phillips. And this is what she had to say.
Dear Mr. Phillips, I will try to tell what I can remember of the conditions of the storm. We heard a weather broadcast from KFH on our radio sometime in the evening around 5:30 or 6 p.m. that forecast severe thunder and electrical storms for the night, but no tornado warnings. At about 9:50, a wind started blowing and I got out of bed to close a window. I was extremely nervous but tried to calm myself and to feel confident that it would be no worse. My oldest daughter was in bed by an east wall, and it was close to 10:10 when she remarked that the wall was shaking. A north window blew out almost before she finished speaking. The next thing I remember is rolling over and over with my little boy in my arms. There was no warning rumble or any other noise immediately before the tornado hit. I can remember hearing lumber and debris flying overhead, but I didn't know where I was or what direction things were flying. I can remember screaming for God to have mercy on us, and the wind was so strong it literally tore the words out of my mouth. A few minutes later, I was found sitting up, saying, "I can't believe it," over and over. I lost 5 children in the storm. Mrs. Raymond King, Oxford, Kansas.
And there was still one more town in the path of tornado number 4, and the name of that town is Udall. Just about 10:30 in the darkness, they would have heard something like this. And then it was gone as quickly as it had arrived. For an hour and a half, Udall lay bleeding and mortally wounded. It took that much time for a passing motorist to realize what had happened and call the Sumner County Sheriff to summon help. In Udall, 77 people died. 5 children at the King Farm and 20 in Blackwell, bringing the death toll for that night's supercell thunderstorm to 102. I often refer to that era as the dark ages of meteorology. Udall completely gone, 95% of the buildings in the town destroyed, the other 5% damaged. And we refused to issue tornado warnings. Now, you think, after all of these triple-digit tornadoes, that President Eisenhower would have said, we have to start a program to warn of tornadoes. But he didn't do that, even though he was from Kansas. You would have think Congress would have passed a law. Nope. You would have thought the chief of the Weather Bureau would have said, we're going to get in the tornado warning business. Actually, it was the other way around. He was against it. What happened was, May 20th, 1957, a tornado, retrospectively rated as F5, touched down near Williamsburg, Kansas, began moving to the northeast, and moved across the south part of Kansas City. And the man you see at lower right, Joe Ogsley, had been the Navy's meteorologist at both the battles of Iwo Jima and Okinawa during World War II. And he said, as he was watching the converted World War II radar, he had a pain in the pit of his stomach that was worse than anything he had experienced during those battles. And he told me later he felt an obligation to his fellow citizens and neighbors, and he issued what we would call today a tornado warning. He told them at about 10-minute intervals where the tornado was going and where it was moving toward. And this tornado that went across a far more heavily populated area than any of the tornadoes I have mentioned killed 44 people. While today, that's a big number. Back then, it was a very small number for a tornado of this intensity. Now, up here, at upper right, you see Blue Ridge Road. If you take this another 8 blocks to the north, a little boy by the name of Mike Smith was growing up. And because we had debris in our yard from the tornado, and because we were so close, we were inside the area where they declared martial law. And so the next morning, my mom took my 2 brothers and me, and we drove through Ground Zero. And I had this thought. I remember, at age 61, I remember what I was looking at when I thought to myself that anything that could do all this had to be pretty interesting. And I knew I was going to be a meteorologist. Well, things started happening very, very quickly. It turns out that as a result of UGA, an experimental Doppler radar was placed in Wichita. And in June of 1958, with having to get up on top of this little truck and manually turn the antennas, they measured a 206-mile-an-hour wind in the fatal tornado that hit El Dorado, Kansas. And so we knew that Doppler radar could be used as a tool to warn people of tornadoes. What none of us ever thought is it would take 2 generations of meteorologists before that became a reality. During the 1960s and through the 1990s, research accelerated very quickly. The storm chase program was born in 1972. And 1 year later, we lucked out. 2 chase teams and 2 experimental Doppler radars at NFSL caught the entire life cycle of the Union City, Oklahoma tornado. And some of that research became the basis of the next RAD program, or the WSR 88D, and would become the basis for saving many lives in the future. And the person who ran that program is Don Burgess, the same person who saw his first tornado the night of the Udall storm. Meteorology is a very small profession. The research got more and more sophisticated, and by the early to mid-1990s, a network of Doppler radars was installed across the United States. But it wasn't just the research and government sectors that were contributing. Will you look at this handsome guy with more up here and less here? Kavoris, with its revolutionary radar, the ability to send radar images from one place to another. Color radar, done for the first time in Wichita, Kansas in July of 1976. Station radars were mushrooming across the country. And then, since 2000, we developed a device called a Storm Hawk that will allow people in the field to send reports of severe weather in real time with GPS precision without ever even picking up a phone. Was this done as a result of a $5 billion program authorized by Congress? Well, the next RADs taken together cost that much. But it was individual meteorologists, many of them, who were working hard, in some cases bucking the bureaucracy, to make all of this happen. This 40 years of hard work, of technology development, of dedication, was in place on Friday, May 4th, 2007. Now, 2007, the economy was still good. The town of Greensburg, Kansas, served by the Union Pacific Railroad, was seeing a train about every 45 minutes. Richard Huckreed was still behind the counter at Hunter's Rexall Drugs, where he had been every day since 1952, making cherry phosphates and ice cream sodas the old-fashioned way. But even though the sky was mostly sunny with only a few cumulus clouds, our client, KWCH-TV in Wichita, which serves the western three-quarters of Kansas, knew things were not as they seemed. They sent 3 chase teams to western Kansas. Now, I doubt any of you have ever been to southern Kansas as tourists, but if you have, the chances are you've been in front of the world's largest hand-dug well. It is a well-known tourist attraction in southwest and south central Kansas. This is the old hand-dug well museum. You can see the water tower says Big Well, and you see this tree. Now, Greensburg the year before had been designated Tree City, USA. It was well known for its gorgeous trees. And Lance and Cindy, the chase team that had been sent to Greensburg by Channel 12, were sitting underneath this tree having a sandwich about 5 o'clock, saying to themselves what a lovely little town Greensburg is. When the 6 o'clock news went on the air, the sky was still fair in Greensburg, a few towering Q and Cirrus, and at 6:10, Merrill Teller went on the air, the chief meteorologist, and said, a tornado watch has just been issued for southwestern Kansas. But by 7, the few thunderstorms in northwest Oklahoma were starting to weaken. And if you went to stormtrack.org, you saw meteorologists saying, this tornado watch may be a bust. Well, it wasn't. Exactly 1 hour later, thunderstorms started exploding in over 4,000 joules of CAPE on a little boundary that had parked in that area earlier in the day. Lance and Cindy moved south to the town of Coldwater so that they could intercept the storms coming from south to north. Lance took this photograph of a low-hanging, rotating wall cloud crossing U.S. Highway 160. 3 or 4 minutes later, the wall cloud was getting better organized and funnels were starting to form from it. Now remember I said there were 3 chase teams? Scott Roberts, who'd been sent to Dodge City, sent this report of a funnel cloud at 9 o'clock via his Stormhawk well to the southwest of Greensburg. And finally, with the very last sliver of daylight, Lance took this photograph of what was going to become the Greensburg tornado as it made its way to the ground. Now, AccuWeather Enterprise Solutions is in the business of helping other businesses make good decisions about extreme weather. And one of our clients is the Union Pacific Railroad. We issue what are called track-specific, mile-by-mile warnings to allow the railroad to get their trains out of the area before a tornado occurs or before a flash flood would wash out the tracks. We saw Scott's report of the funnel cloud. We saw the increasing rotation on radar. And at 9:10, we issued a tornado warning for the Union Pacific at Greensburg. And rather than me tell you about it, I'm going to play a tape of the dispatcher calling the train so they would know where and when to stop.
Dispatcher summary to UP 4307 west, over. UP
4307 west, over.
Guys, don't get in too big of a hurry to go westbound. I got a tornado warning around 325, between 325 and my course 342 until 2200, so about another 35 more minutes. I expect a little bit of a delay there at Wellsford, over.
I'd understand you got tornado warnings from milepost 325 to milepost 342. Be up in about 35 minutes. We'll just slow roll over.
All right, guys, I appreciate that. Thank you, Al.
Thank you, sir. UP 4307 westbound.
And they stopped one eastbound train to the west of Greensburg, and so you had these 2 trains stopped at the edges of the tornado warning. By this time, the tornado was now 3/4 of a mile wide. It was gaining in strength and intensity. 9 minutes after we issued our warning, the National Weather Service in Dodge City issued its tornado warning for Kiowa County, including Greensburg. There was 1 tornado siren in Greensburg at that time. It was old. The standard procedure was to sound the siren for 5 minutes and then not sound it again, turn it off for fear of burning it out. But because the emergency manager had heard the reports of this tornado taking out farms to the south of town, he made the decision to leave the siren running. And it continued to sound until the power failed. At 9:25, you had the classic hook echo to the south-southwest of Greensburg, moving to the north. By 9:30, all three of the television stations in Wichita were in continuous coverage. And at 9:35, this is what the Dodge City velocities looked like. You had over 200 miles an hour of shear. The tornado was now over 1 mile wide. And if you look very carefully, see those telephone poles? 4 miles of them fell moments after this picture was taken. The north half fell to the west, the south half fell to the east. This is what the TV stations were saying as of 9:40.
This is the wind part, the Doppler part of high-resolution X-ray Doppler radar. Greens, winds blowing toward the radar in Dodge City, pinks away, so the center of circulation is right there, and you can look and just count. That's 1, 2, 3, 4 miles to the south of Greensburg. So now if we go back here and we take a look at where we've tracked it, 1, 2, 3, 4, we're just about right on the money, an arrival time of 9:48. So you got about 8 or 9 minutes, Greensburg. This is going to be an extremely close call, and we urge you to go ahead and move to shelter and stay there if you are not already. We'll continue to keep you updated.
And finally, at 9:52, the now 1.7 mile wide tornado was nearly perfectly aligned with the 1.7 mile wide town. And it moved from south to north across Greensburg. Immediately following the tornado were storm chasers Darren Bierman and Dick McGowan, both certified EMTs. The debris had not even stopped falling before they were pulling on their work shoes and their work gloves and pulled into Greensburg to begin rescuing people. This is the scene as they pulled into town. And 1 minute after that, 2 minutes after the tornado exited the north side of Greensburg, this is the coverage on KWCH, our client.
Thing two, we're trying to get up behind it to see exactly where it's at now. I'm not sure how far we're going to get, though, with all the traffic that they got stopped. Looks like they got the roads closed off up here a little ways.
Okay, and alrighty, so thank you for that information. Storm Team 12, Storm Chaser Lance Ferguson. Lance's location, you can see the Storm Hawk on the left side of the screen there at 9:58. Thank you, Rodney. Rodney Price working the Select Orange Super Doppler radar right now, showing you where Lance is, and as he's looking in toward the storm. Again, the reports that he has gotten from officials there of a couple of homes destroyed to the south of Greensburg. Again, this storm, as you can see from the information on there, one of the storm reports at 9:38 had the tornado just along Highway 183 to the south-southwest of Greensburg. It has now passed over the east part of Greensburg, is now northeast of town, and continuing to move northeastward into the northeastern sections of Kiowa County. That storm moving northeast at 30 miles per hour. Okay, now, the Dodge City National Weather Service has just sent down a report saying Greensburg has appeared to have taken a direct hit from a violent tornado. This via EMS reports. Now, again...
I want you to think about that. 3 minutes after the tornado exited the north side of town, Greensburg has taken a direct hit from a violent tornado. It wasn't 90 minutes like it was in Utah. At hearing those words, the operations director for Midwest Life Flight was picking up her car keys, heading to Jabera Airport, scrambling the medical helicopters they owned in Dodge City and Wichita, and by 10:20, the first medical helicopter was landing in Greensburg. Unfortunately, the worst had happened. 95% of the buildings in Greensburg were destroyed. The other 5% were damaged. My friend Larry Schwann, who was a native of Greensburg, told me it was very odd that by simply standing erect, you were the tallest thing that wasn't damaged. The Wichita Eagle the next day ran a one-word headline, devastated. And certainly that's accurate. But I would have chosen a different headline, and that is miracle. A miracle of science. Here's why. The Greensburg and Udall tornadoes will probably end up being the most identical F5 tornadoes in history. They occurred at the same time of night, complete darkness. They both approached from the south rather than more common southwest. If you had been out looking for them, you couldn't see them because of the approach cloaked by heavy rain and hail. They occurred in the same state with the same building codes and construction type, and both destroyed 95% of the buildings in their respective towns. And in fact, if you look at pictures of Greensburg on the left and Udall on the right, the damage is remarkably similar, including the mode of failure of each town's water towers. As I was doing my research for my book, Warnings, there was something that bugged me about the radar tracing from Udall and the radar data from Greensburg. And really, this went on weeks. I couldn't figure out what it was. And then I had an inspiration. I took the tracing and the radar data to Wichita artist Trina Sanders, and I said, I want you to scale them and place them on top of each other. But I don't want to show it to you. I don't want to coach you. I want to see what it actually looks like. This is what the Greensburg echoes look like on top of the Udall tracings. I don't think we will ever have two more similar F5 tornadoes. But even though these tornadoes were nearly identical, thanks to the warning system, we had very different outcomes. Udall became known as the town that died in its sleep. 77 were killed out of a population of 505. The 5 that were killed at the home in Oxford brought the death toll to 82. In Greensburg, you had excellent warnings, 12 killed out of a population of 1,500. Now, looking at this another way, if you take the larger population of Greensburg and multiply it by the death rate in Udall, meaning no warnings, you would have had 243 killed. You actually had 12 killed, which means that 231 lives were saved that evening. Now remember, a couple of years later, when Sully Sullenberger landed the plane in the Hudson River and saved about 120 people's lives. That was wonderful. And the crew, the 2 pilots, the 3 flight attendants, were taken from place to place. They were guests of honor at the Super Bowl. They had a ticker tape parade in downtown New York, and they deserved every bit of the praise they received. But this is twice the number. And Captain Sullenberger saved his own life. He was on the plane. But the storm chasers, the storm warning meteorologists, they were doing their job, and the storm chasers were risking their lives to save other people. Where is the similar praise in the meteorological profession? Part of the reason we don't get the kudos that I believe we deserve is because when we do our job well, nothing happens. See this picture? You obviously see destroyed Greensburg. But what's important about this picture is what you don't see. And what you don't see is no train on its side. Union Pacific has a traffic simulator, and they reran that evening without our storm warning, and both trains would have been in Greensburg at the time of the tornado, one on the passing siding, the other on the main line, and our warnings prevented 2 trains from being destroyed, hazardous materials from being spread, over $10 million of damage, not to mention the lives of the train crews. When Greensburg had its 5th anniversary of its rebuilding, they were kind enough to invite me. The town has become a gem on the High Plains. It is absolutely wonderful what they have done. Their goal is to be the greenest town in America. And the new tornado and world's largest hand-dug well museum is absolutely magnificent. It is wonderful. You need to be there if you're in that part of the country. Success. Greensburg has had a lot of publicity because of its green rebuilding. And the town, after a few false starts, is now flourishing as a result of the tornado. But Mayor Bob Dixon told me, and he's told every meteorologist, that if we had lost 200 or more of our citizens in that tornado, it would have been the end of the town. He says meteorologists didn't just save lives, they saved the town. And if you go back 5 days ago, we probably saved 10,000 lives in India. Meteorology is one of the most noble professions. In the recent shutdown, many National Weather Service employees continue to come to work without pay. That is dedication. Meteorologists as a group are very dedicated and very public service oriented, whether they are in research, government, or private sector. So this is the field you've chosen for yourself, students, and you should be very proud of it. Now, I mentioned my 2 books. If any of you happen to have copies with you, I would be more than happy to autograph them. There's no such thing as an author that does not want to autograph his or her books. And then, I am now the weather expert at answers.com. That is my email address, my phone number, and I also have a personal blog at mikesmithenterprises.com/blog. I would be more than happy to answer any questions you might have. And then if you all want, I'll do a little bit of my Joplin presentation about how things went wrong that day. And because things went wrong that day, we went right back to triple-digit fatalities, 161 killed in that storm, which proves, in a way, the value of the tornado warning system. Take away the storm warnings, or at least the effective storm warnings, and the death tolls go right back up. But first, any questions? I do want to talk about tornadoes, but I wanted to give you this little bit of an intro. It was the research that was done into Doppler radar and severe storms. It was the work of the government putting out the NEXRADs and issuing the tornado warning for the public. And it was the warning from AccuWeather Enterprise Solutions that kept those 2 trains from derailing. It's a partnership. And all 3 areas, whether it's broadcast, whether it's a private sector company like AccuWeather, all 3 are valuable and important in order to save the most lives. So questions? Yes?
Mike, thank you for coming, and I enjoyed your presentation a lot. Could you talk a little bit about the role of the storm chasers in the Greensburg situation?
Yes.
And of course, we unfortunately lost some colleagues storm chasing in the El Reno tornado this year. So what are your thoughts on chasing, as a whole? And obviously they can provide a service, but at a great risk. So any thoughts on that?
Considering that formalized storm chasing has been since 1972, and it took until 2013 to have any direct deaths, for chasers who know what they're doing, I would contend the risk is not that great. Now, there was an amateur chaser who was killed that day as well on his first ever storm chase. Those of us in Tornado Alley spend a great deal of time counseling people not to chase storms, not to go outside. But I will tell you, I was once chasing and reporting to the NWS near Medicine Lodge, Kansas, and apparently it became obvious to some locals what I was doing, and I suddenly found myself in a 3-car motorcade because I could not lose the locals. And we're finding out these days it is the locals that often cause the problem, not the real storm chasers. I did check. I photographed the tornado coming toward Wichita on the 19th of May of this year, and I had checked with the NWS, and yes, they are getting tweets from chasers in the field. They're getting storm hawk reports, so that is useful. I also had no problems with the storm chase tours. People would do that less safely if they really want to see a tornado. Where I have the problem is the locals who have no idea what they're doing, and they're going out there. I have a photograph of the May 19th situation all the way down Clearwater Road, and there's not a single storm chaser on the pavement, with the exception of the Doppler on wheels, and that's fine. It needs a level. But every one of the chasers is completely off the highway, not causing any problem whatsoever. Other questions? Yes?
I'm just curious about your thoughts on how the public understands the warning system in general. Do you think they understand it?
I can't speak for northern Georgia, but throughout Tornado Alley, yes, they know the difference between a watch and a warning. They know what to do if a tornado approaches. Now, there's an increasing amount of evidence that tornado lead time is optimally about 15 minutes. I think these ideas of putting out tornado warnings 2 hours in advance are misguided. I think that's going to cause many, many more problems if it's done than it would solve. But in places like Birmingham, I know those folks are really well educated. I know that Kansas, Oklahoma, Nebraska, Iowa, Missouri, that area, they know what to do. Other questions? All right. Yes, go ahead.
When you're making a decision to stop trains like in Greensburg, how many meteorologists are making that decision?
One. We divide them up by how active the country is. We may have as many as 7 on duty at one time doing that, but that's the decision made by a single meteorologist. Now, he and she has a lot of technology, but the ultimate decision is made by the meteorologist, and they do a damn good job of it. All right. Yes, John.
Could you speak to educational needs? I've heard you talk about it before. I want you to give it to them here. What do juniors and seniors and freshmen and sophomores need to be doing and learning?
Okay. Well, that's exactly where I was going to go. Thank you. Number 1, communication skills. It makes no difference whatsoever whether you're going into broadcasting or not. If you can't write, if you can't speak well, your chances of doing well in meteorology, especially private sector meteorology, for which I include broadcast, are very low. Private sector meteorology demands good communication skills. If you get a job interview in the Wichita office of AccuWeather, you will take a meteorology test, and that will include how well you write. Our meteorologists must be able to communicate. Secondly, get as much forecasting and practical experience as you can. That is very important. Theory is important, but practitioners need to actually practice. And some of your mistakes need to be made in college rather than on the job. If you come to work to the Wichita office, even if you're well qualified, it's going to be 3 or 4 months before you ever issue your first storm warning to a client, even if you're a degree, well, we only hire degree meteorologists, but we have such an extensive training program, we don't let anybody touch a storm warning until they have been through it and passed it. And if you don't pass it the first time, you're going to have to take it again. Until you pass, you do not issue a storm warning for our clients. We have very high standards for what we do. Fortunately, we have a fantastic team with very high morale that get the job done and enjoy working there. One of the things that I think we've done very, very well is create a teamwork atmosphere, and that's part of it too. we were talking earlier today, there are some that advise meteorology and science students not to put McDonald's on your resume if you've worked there. I urge you to do so. If you have worked at McDonald's, put it on your resume. It demonstrates that you can work in a team atmosphere, and it demonstrates you can work with customers. And without our customers, we're nothing. We have to have our customers. Remember, there's a free version of what we do. And if we don't provide significant value, those clients that are paying us 6 figures a year will go away very, very quickly. Other questions?
As far as on-air goes, doing cut-ins to issue a storm warning if
Yes.
the National Weather Service hasn't issued a tornado warning, what's your take on that?
What I've always done, and I think works fairly well, is I reserve the term watch and warning for the National Weather Service. What I do, and this happened during my broadcast career a number of times, is I will go on the air and say, we have a hook echo, we have a thunderstorm that is showing suspicious signs. I'll use, instead of saying it's a right mover, I'll say, or I will put the Doppler on and show that there's rotation and that it's increasing. And so I will say that if you are in the path of this storm, it's got the potential to cause a tornado, and you may want to seriously consider taking cover. That's what I will say, but I reserve the term watch and warning to the National Weather Service. There's nothing legal about, I can call it a tornado warning. I prefer not to, so I don't engender confusion.
Now, do most stations prefer you to do cut-ins if you see something like that?
If you are sufficiently experienced, yes, they would prefer you to do that. In the famous Wichita Andover tornado, I warned Andover 7 minutes before the National Weather Service because I couldn't believe it was getting that close to the Butler County line and no tornado warning is issued. And if you look at the tape of that evening, you hear me say people in Augusta, Rose Hill, and Andover need to get into the basement right now. And the tornado hit about 9 minutes later. Unfortunately, the Weather Service only gave them 2 minutes warning. I don't know why they waited till it got so close to the border, but we did provide that service. Did I see? Yes, sir.
So how does your company work with the Weather Service to serve your customers?
We use the Weather Service's raw data, plus we purchase data like lightning data that the Weather Service doesn't collect or create. But when it comes to issuing a tornado warning, it's based on our decision. You saw, for example, we issued the warning for Greensburg for the Union Pacific 9 minutes before the National Weather Service issued their warning for Greensburg. Now, it's not a competition. It's a different mission. The mission of the Weather Service is to warn the public at large. Our mission is to take care of our clients. In the case of Union Pacific, it's extremely difficult to back up a train. They want at least 20 minutes. They prefer more lead time to get their trains stopped and out of the warned area. So we have that client knowledge that they want more lead time than that ideal 15 minutes for the public. And so we're issuing the warning independent of the Weather Service, often before the Weather Service, but it's a different mission. Yes?
I got a quick question.
Sure.
I think some probably would want to hear something about the Joplin. Mike, with the El Reno and more tornadoes, we saw a lot of discussion out there because there were on-air folks who were telling people different things about what to do.
Right.
One of the things we recently did, myself, Keith Sider, and others, we talked to the sort of the station manager industry, the RDTNA.
Our radio, television, news directors.
Yeah, and we were talking about the notion of what would happen if all of the television stations during a situation like those two events were talking to each other as opposed to maybe competing with each other. What's your take on it? Because
A, that will never happen.
I know.
B, if it did, it would probably be illegal. The FCC or Federal Trade Commission could construe that as collusion.
Collusion?
Yes.
Yeah.
But secondly, you got to remember, that's exactly what the National Weather Service tells you to do.
Right.
The day before, we had a tornado heading straight. Well, here's a photograph of as it first touched down. We had an EF3, and it looked like it was going to be another Joplin, and there was so much hail, I believe it got undercut by the rear flank downdraft, and all over town, including yours truly, we were chasing it, could hear the roar. I mean, people all over Wichita could hear the roar of a jet plane, but there was no jet plane flying in this thunderstorm. It was the tornado 200 or 300 feet above the ground. But fortunately, you had 60, 70, 80 mile an hour straight winds, large hail. My house had almost $30,000 worth of damage, broken windows and everything. But the tornado circulation couldn't get to the ground because it was undercut by the cold air. Why am I telling you this? The central region of the Weather Service has something called impact-based warnings, which is an absolutely horrible idea, in my opinion. And they tell you explicitly, you will die if you are not underground. You may want to, those without basements may want to travel to a place with a basement. I can show you, it's on my computer. That's exactly what they say. So it's kind of hypocritical for some of the people in the Weather Service to complain about the TV station saying that on May 20th when the National Weather Service was saying that on May 19th. And in fact, 3 times they pressed the panic button in the Wichita area with the "you're going to die." They call it the deadly tornado. And there's been no damage in any of the 3. We do not have the scientific knowledge needed to tell people in advance what the intensity of a particular tornado is going to be. We should not try to do things for which there is no science to support it. Sorry, but I'm pretty passionate on this subject. It is hypocritical to complain about the TV stations when the Weather Service was doing the same thing.
And I need your philosophy. I just want to hear you.
Oh, okay. Yes, go ahead.
Speaking of science, what do you see as the bridge or connection, or how can both sides benefit between academia and the private sector?
One of the things we did for 3 years, and then we kind of ran out of money, post September 11th was very, very hard on our business because we often come out of the security department budget, and all the CEOs, you'll remember there was a recession already in progress, and they said, okay, get rid of those weather guys, we need to reinforce our terrorism, whatever that would be for an IBM. So we lost a lot of business and couldn't continue doing that. But what we did is we had something called the seminars for 10 meteorology professors around the country. And we actually put them through our weather test. We made them make forecasts. We made them sit down and actually replay a severe weather situation. What would you do? We talked about how they should be approaching the students, because let's face it, there are more jobs in the private sector these days than there are in the government. And without a single exception, they all rated it 10 on a scale of 10. But sort of like when something like that loses momentum, it kind of loses momentum, and we haven't done it since. I know that's kind of a long-winded predicate. My answer is, and what we were trying to do, is to teach professors what their students need to know in the field, and what the problems are that companies actually deal with. One time we had one of our customers come in and talk to them. The other time we had it over speakerphone. And so we had like the vice president of Westar Energy telling them what the students needed to know. And I think my personal opinion is there is a place for theoretical research and there's a place for applied research. And in academia, in meteorology today, it seems the scale is a little bit too tilted toward theoretical research rather than applied research. We do a lot of research. Go to our website and look at white papers and things like that. All that's public. It's all on the website. I sent Marshall and John today a copy of a new white paper that was just published today. But I think it's asking a little much for companies like AccuWeather to do all of the heavy lifting in applied meteorology. I think there is a role for academia to do that.
Where do you see the biggest deficit in applied meteorology research right now?
Number one, we are over tilted toward extreme weather. There is a lot, 2 inches of snow can cause a lot of problems. An extreme change in temperature can cause a lot of problems. I've looked really hard and I can't find a non-computer-based temperature forecasting technique in the literature past the 1970s. It may be there, but I haven't found it. It's all model, 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 model. Well, models don't do everything. We were just talking in the forecast contest this afternoon. The model was forecasting 1/3 of an inch of precip with a temperature of 40 and a dew point of 20. I guarantee you, if it's precipitating with a temperature of 40 and a dew point of 20, that temperature is going to be lower as it falls down toward the wet bulb temperature. Models do a terrible job of this, but it can mean millions to an electric utility. Secondly, while we do a really good job of forecasting blizzards, we marshal all of our resources for that. We kind of treat, well, maybe not here, but in Kansas, we treat 2 inches of snow as no big deal.
That's a huge deal.
It's a huge deal even in Kansas. There are traffic accidents and people are delayed and deliveries are delayed. We need to spend a little more time on day-to-day, at what I would call adverse weather, as opposed to extreme weather. I think there's a lot of room for that. John?
And I'll maybe bring it full circle back to the students. What is your opinion of the value of additional education? Beyond yeah, I want to hear you say it because I heard you talk about this probably about 13 years ago, and things have kind of changed because now it's harder, I think, for students to get jobs at the undergraduate level, and they hear the siren song of graduate education. So this is your chance.
If you are going to go into television, or if you're going to work as a forecaster at AccuWeather Enterprise Solutions, most master's degree programs have very little, if any, value. I realize that's shocking. I realize that's often not what the faculty want to hear. I said that once at the University of Oklahoma, and I thought I was going to be stoned. Tonight I would have had chicken nuggets thrown in. And as one woman said, young woman said very loudly from the audience, she asked, the question was, how much more will you pay us because you have a master's degree? And I said, well, it depends. If the master's degree is applicable to what we do, we will definitely pay you more by a significant amount. But if it has nothing to do with where we are, we'll pay you very little, if anything, extra. And I mean, the whole room just erupted. And I said, look, guys, in the private sector, you get paid for the value you bring to the job. The credentials get you in the door, but you get paid for the value that you bring. And that really hasn't changed. Now, I don't want you to think I'm against master's degrees. I'm not against them. But anybody who thinks they're going to get a starting salary of $15,000 more because you have a master's degree, it ain't going to happen. At least not in the private sector. And that's pretty, I can almost say to a man and to a woman, that's what a TV station general manager would tell you also.
Yeah, I think, just to be real, I've told some students, I've told students the same thing that those going into the broadcast field.
Right.
I think the thing to focus on in the broadcast field is being able to get things like this, the seals and the certifications.
Right.
Those kind of things.
Absolutely.
Yeah.
Absolutely. Those are valuable.
Those are valuable.
But I can't, in good conscience, tell you a master's is going to help you get a job at a TV station. I don't think it will. Maybe it would be a tiebreaker between two almost identical students, credential-wise, but it's not going to be much more than that. And I'm sorry to have to say that, but it's accurate. Okay, what else?
How long did your Joplin?
It takes about 10 minutes.
You guys want to?
Would you like? Okay.
Because I know for you have to drive back to Atlanta.
Yeah, I do. But I would love to do the Joplin presentation because this is what can go wrong. And anyone in this room who's thinking of a career in broadcasting, needs to pay attention, especially to this presentation. May 22nd, 2011 was an ordinary Sunday in May. We had had the record tornadoes of April 27th, just a couple of weeks before. We had had a F4 tornado go across St. Louis, 0 fatalities. It had been an extremely active year. The Joplin High School Eagles were graduating their second largest class in history, so much so they had to move their graduation to Missouri Southern University, which turned out to be a stroke of luck of the first order. Normally, the graduation is held in the gymnasium. That gymnasium was completely flattened about 20 minutes after the graduation ceremony ended. There was a wedding going on at Steinhouse Gardens, southwest of Joplin, and they scrambled to move the wedding up earlier because they had the forecast of bad weather later in the day. At 1:30 that afternoon, the Storm Prediction Center issued a tornado watch. Now, you know, in May in this part of the country, there's nothing particularly unusual about that. But in Joplin, that watch was received with a different filter than most people here in Georgia or in Kansas would have. And let me explain why. From January 1, 2008 to December 31st, 2011, Craig County of Oklahoma, which is handled by the Tulsa Weather Service Office, had 4 tornadoes and 7 tornado warnings. Ottawa County had 2 tornadoes and 7 tornado warnings. Nothing particularly unusual about that. But you cross the border into Missouri and you go into Springfield's county warning area. And you had 2 tornadoes, including the big one, and 34 tornado warnings. It was like magic. The minute an appropriately warned severe thunderstorm crossed the border, immediately a tornado warning would go out. In addition to these 34 tornado warnings for which the city of Joplin sounded its sirens, the 24 consecutive tornado warnings for Jasper County, Missouri, not just the city of Joplin, were false alarms. And since 1973, sirens in Jasper County were activated for both tornado and severe thunderstorm warnings. That dates back